Okay, guys, this is our asynchronous day assignment where I'm having you guys watch this video, which I'm embedding into the Edpuzzle, and I'm going over your homework for Half-Life. So we're going to look at this problem here, which is how much of a 100-gram sample of gold, which has a mass of 198, is left after 8.10 days if its half-life is 2.70 days. Okay, so let me get to our whiteboard and we'll walk you through this problem. All right, well, if you remember, let's see, we have 100 grams of the isotope of gold, and it says that its half-life, I'll abbreviate half-life here, is 2.70 days. Okay, and then, so how much is left? How much left after 8.10 days? All right, well, first we need to figure out how many half-lives have gone by. And the way you do that is you're just going to divide. So we had a total of 8.10 days go by. We said the half-life was 2.70 days. So you put that in your calculator and you get 3 half-lives. Okay, so that's how many half-lives have gone by. So if you remember, a half-life is how long it takes for half of the element to decay away. And the way I do it is I set up a little table. Okay, got your mass and the half-lives that have gone by. So at 0 half-lives, okay, which is how much we started with, which is 100 grams. Okay, and we said that there were how many half-lives? Total of 3, right? So after 1 half-life has gone by, what's 100? What's half of 100? Or 100 divided by 2, however you want to say it. You get 50 grams left over after 1 half-life. Okay, another half-life goes by, and what's half of 50? 25. Another half-life goes by, what's half of 25? 12.5. And we could stop at this point because we said only 3 half-lives have gone by. We've done it for 3 half-lives. Your answer is you have 12.5 grams of gold left over after 8.10 days have passed. Okay, next problem. Go back and look. Homework. Our next problem was a 50-gram sample of nitrogen-16 decays to 12.5 grams in 14.4 seconds. What is its half-life? This one's a little bit different. This one says we have a 50-gram sample. That's how much we start out with. Of nitrogen-16 isotope. Okay, and this is going to decay into 12.5 grams in 14.4 seconds. All right. And they want to know, what is the half-life? Is the half-life. Okay. So what I do is I'm going to try to figure out how many half-lives have gone by. I'm just going to look at what we start with. I said that we started with 50 grams, right? Okay, that should be at 0 half-lives. Okay, let's start breaking it down after 1 half-life. And then after another half-life. And look, that's what we had in 14.4 seconds. So now we know it's 2 half-lives. All right, now we're not done because Now we got to see, we have 14.4 seconds. It was the amount of time that went by. Okay, right there. And we know that there was 2 half-lives, so let's divide that by 2. And that gives you 7.2 seconds. Okay, that's the half-life of nitrogen-16. That's a 6, by the way. Okay. All right, so you just got to basically run through the math with these. It's not hard. It's just, you know, I'm going to go back and share my homework with you here so you can see what our next problem is. Half-life of S-potassium-42 is 12.4 hours. How much of a 750 gram sample is left after 62 hours? All right, so we are starting with potassium-42. All right, half-life is equal to 12.4 hours. We have a 750 gram sample, and they want to know how much is left after 62 hours. All right. So let's see how many half-lives have passed. We said 62 hours have gone by. Or see how many half-lives are in our total amount of time that have passed. So we had 62 hours. We said the half-life is 12.4 hours. All right, put that into the calculator, and it's going to tell you 5 times. That's a total of 5 half-lives. All right, remember what I said? I always set up a nice little table. You got your mass, you got your half-lives. Okay, so we got to carry this one out. Running out of space, we'll put number 5 over here. All right, so at 0 time, it says 750 grams. So we start out with 750 grams. 1 half-life is going by. What's half of 750? 375 grams. Okay, that's after 1 half-life. After a second half-life, we have to take half of 375. You can plug that in the calculator if needed. That's 187.5 grams after 2 half-lives. Plug 187.5 in the calculator, divide it by 2, and that gives you 93.75 grams. Got to divide that in half for our 4th half-life, 46.875 grams. And one more time over here for our 5th half-life, if you plug in 46.87 divided by 2, it's going to give you 23.437 grams. So your answer for this, we're going to look at our sig figs here because everything has got your, you know, the decimals everywhere, well, except for the 750. But we're going to answer this with 23.4 grams. Just round it. Is how much you will have left of the potassium. All right, let's look at the next one. Number 4, what's the half-life of, I think that's TC. I have to look on the periodic table with element, but 99 is its mass. If 500 gram sample decays to 62.5 grams and 639,000 years. All right, we got some big numbers in this one, but you got a calculator, so no worries. All right, so we have our 99 TC is our element. We have a 500 gram sample. It says that it decays into a 62.5 gram sample after 639,000 years. This one takes a while to break down. All right. They want to know what the half-life is. So let's figure out how many half-lives have taken place to go from 500 to 6250. So 500, that's at our 0 mark. After one half-life, 250. 2 half-lives, 5. After 3 half-lives, you get 62.5, which is where we need to be. All right, so 3 half-lives have gone by. So how we figure out the half-life? We take the amount of time that has passed and divide it by the 3 half-lives. And that is going to tell you that 213,000 years is the half-life of this element. Okay, here's your answer. All right, our next one. All right, I was supposed to share the next one with you. All right, got 2 more to go. All right, so thorium 232, the half-life is 1.4 times 10 to the 10th years. If there is a 25-gram sample, and the left after 2.8 times 10 to the 10 years, how many grams from the original sample? So let's get back to our whiteboard. All right, and for this one, we have thorium 232. Okay, we have a 500-gram sample. Oh, wait, sorry. That's one of the wrong one. We have a they give you the half-life. All right, so half-life is 1.4 times 10 to the 10th years. And if there is 25 grams left after 2.8. All right, so we have 25 grams left after 2.8 times 10 to the 10. How many grams were in the original sample? How many grams in the original sample? All right, well, first, let's see how many half-lives have gone by. All right, so we said the amount of time that it's passed is 2.8 times 10 to the 10th. And we said the half-life are 1.4. I mean, you can do that in your head. 1.4. Well, 1.4 plus 1.4 is 2.8. So, and then remember your exponents here are the same. So you've had 2 half-lives go by. Didn't even need a calculator. All right, so we know if you had 25 grams at the end, all right, this is the number you ended up with. So basically, you're just going to take, you can do your chart if you want to. You don't really have to with this one either. Okay, 1 half-life, 2 half-life. So we said we had 25 grams at the end. All right, so we're just backing up. So what did you have to have here that went in half to make 25? It was 50. Okay, and then what did we have to start with to get to 50 here? Well, it was 100. 100 divided by 2 is 50. 50 divided by 2 is 25. All right, so our original sample was 100 grams. Okay, so the math wasn't all that hard with that one. You just had to kind of figure out how to back into the answer. All right, our last one. Let's go back and look and see. So this one says you had a 5 grams of iodine 131 left after 40.35 days. How many grams were in the original sample if its half-life is 8.07 days? All right, let's clear this out so we can get our last one done. Okay, so it says we had, this is iodine 131, and half-life, it tells us, is 8.07 days. Okay. It says that after 40.35 days, there is 5 grams left. And they want to know the original sample. How many grams in the original sample? All right, so again, let's figure out how many half-lives have gone by. So our half-life is 8.07, and we know that 40.35 days have gone by. So you're just going to divide your total number of days by the half-life. And when you plug that into your calculator, it's going to come out as 5. It's a 5 half-life. We set up our chart. I said, if you have a better way of doing this, this is just a way to keep me straight. 0, 1, 2, 3, 4, 5. All right. It says there's 5 grams left. So we're going to actually start here, and we got to back our way into it. Well, what do you have to have here to get 5 grams? Well, it's 10. And what do you have to have here to half it to get 10 here? That's 20. And so you're just backing into the numbers. What do you have to have here divided by 2 to get to 20? That's 40. Okay, so this is easy. What divided by 2 equals 40? That's 80. And what divided by 2 here is going to give you 80. 160. Okay, so hopefully you know math. You could do that with your calculator too. So, but so we had 160 grams of iodine 131 originally. That's your answer. Hopefully that makes sense. If you guys have questions, please let me know. But other than that, that was your homework, and hopefully you got them all right. Have a good one.